So yes, we are live. Good morning everyone. Welcome to previous year paper solution class. So in the today's class, we are going to see Telecom Gate 2020 PYQs of Signal and System subject. Let us start with the very first question. So the first question in front of a screen, check it out. The transfer function of a stable discrete time LTI system is h of z, that is equal to k times z minus alpha upon z plus 0.5, where k and alpha are real numbers. The value of alpha rounded off to one decimal place with mod alpha should be greater than 1, for which the magnitude response of the system is constant over all frequencies is dash. So this is NAT 2 marker question. Try it out. Your time starts now. So the question is not that tough because they are giving us one hint. What is the hint? That the magnitude response of this system is constant over all the frequencies. What does this mean? Sir, this means all pass filter. Yes, we have all pass filter. So is there any property in all pass filter? See, in Laplace transform you have studied one property, that is pole zeros are mirror of each other about a j omega axis. But that was in the Laplace transform. But here we have Z transform. So the scenario is different. So the property would be little bit different. But there is again some relationship between poles and zeros. But what is that relationship? Check it out. Okay, last 15 seconds to go. This is just a 1 minute question. Even if you know the property, it's 30-second question in the exam. Okay, so finally 8 seconds. 7, 6, 5, 4, 3, 2, 1. Done. Okay, so now it's my turn to solve this question. Check it out. The first point is they are giving us the magnitude response of the system is constant over all frequencies, which means it is all pass filter. In short, also known as APF, all pass filter. So in the all pass filter, in the discrete time domain, we have a property. So what is the property? Digital all pass filter have conjugate reciprocal pole zero pair. So what does this mean? It simply means if you have 0 represented as z, but let me write it here completely only. If you have 0 represented as z, that is equal to 1 upon, reciprocal means 1 upon. Then we have conjugate pair. Conjugate pair means pole conjugate. Star means conjugate. Okay, so I hope now it's very clear. If you check the question, what is pole and what is 0? Sir, to get the pole denominator equal to 0, to get the zeros numerator equal to 0. Okay, so if I do that, I will get my poles and zeros. So as per the question, h of z was given as k times z minus alpha divided by z plus 0.5. So to get the pole denominator equated to 0, therefore z is equal to minus 0.5. To get the 0, numerator is equated to 0. So z minus alpha, that is equal to 0. You get your zeros as z is equal to alpha. Okay, so this is your pole, this is your 0. Now you know the relationship. The relationship is 0 is equal to 1 upon pole conjugate. So if I use that, then I can say, by using this concept, I can say now that my 0 is alpha, that is equal to 1 upon conjugate of this. So this is a real number. So conjugate of a real number is real number only. So minus 1 upon, or let me write in this way, 1 upon minus 0.5, which is nothing but 1 upon minus half, that is equal to minus 2. Now alpha is equal to minus 2, that is the correct answer. But you will say, sir, they were saying that mod alpha should be greater than 1. They are just saying mod alpha should be greater than 1. They are not asking you about the mod value of alpha. They are just saying that if you have alpha, then if you take the mod of that, the value should be greater than 1, which is happening in our case. So a lot of students thought they were asking us the magnitude of alpha. No. They are not asking the mod of the alpha. They are just saying if you have found the alpha, then check. If I take the mod of alpha, so mod of minus 2, that is equal to 2. Is it greater than 1? If it is greater than 1, then yes, it is absolutely correct answer. Therefore, this is the answer. Okay, so the answer is minus 2. Let us move forward for the next question. So the next question is coming in front of your screen. Check it out. One more good question, but this question requires 2 slides. Okay, so read this slide. Which one of the following pole 0 corresponds to the transfer function of an LTI system characterized by the input-output difference equation given below? So please write it down. This is the difference equation. Y of n, that is equal to summation k is going from 0 to 3 minus 1 to the power k into x of n minus k. Now once you have seen this, do the Z transformation, get the poles zeros and tell me which option is correct. Okay, so see it here. You will get how many terms? K is 0 first term, k is 1, k is 2, k is 3. 4 terms you will get, and then you have to comment on which of the following pole 0 plot is correct. The first option is saying at the origin there is a third order pole, which means the pole is having the values 0, 0, 0. 3 times that value is repeating. Similarly, here also 0, 0, 0, here also third order, but here fourth order. Then talking about the zeros, which is represented by circles. So in the option A, they are saying at 1, okay, so let me say in this way, 1, j, minus j. These are the zeros. Here, minus 1, j, minus j. These are the zeros. Here in between, like you can say that first quadrant on the unit circle, we have a 0. And then minus 1, we have a 0. And here in the fourth quadrant, we have a 0. And here they are saying we have 1, 2, 3, 4. 4 zeros we have. So A, B, C looks familiar, like 3 poles, 3 zeros. D is kind of very different. 4 poles, 4 zeros. So you have to think on that. The time is up. The time is up. Now it's my time to solve the question. So first of all, we will open this. So let me copy. Let me copy. Let me say that the given difference equation is y of n, that is equal to summation k is going from 0 to 3 minus 1 to the power k, then x of n minus k. Correct? So now if k is 0, then we have minus 1 to the power 0, which is 1. And here if I substitute k is 0, then x of n is the output. Then k is 1. So minus 1 to the power 1, negation. Okay, so negation. Here k is 1, so x of n minus 1. Then k is 2. So if k is 2, then minus 1 to the power even is positive 1, and here k is 2 will give you the output x of n minus 2. If you substitute 3 instead of k, then check it out. Minus 1 to the power odd, the answer is minus 1. Therefore, we have to say minus outside, then x of n minus 3. Done. This is my y of n. Now comes the concept. What is the concept, Sirji? The concept is very simple. In the Z transform, x of n has the Z transform capital X of Z. But if the time is shifted, let us say n minus a, then the Z transform says because the time is shifted, raise that to the power of, or not e here because Laplace nahi hai, raise to the power of Z. So Z to the power minus a, then into capital X of Z. Okay, so now check it out. The same scenario is happening here. Therefore, if I take the Z transform, check it out. If I take the Z transform, can I say y of n Z transform would be y of z, that is equal to x of n Z transform is x of z minus whatever is here raised to the power of z, so z to the power minus 1 x of z. Similarly for the next z to the power minus 2 x of z, next minus z to the power minus 3 x of z. Okay, therefore the transfer function that is equal to output by input looks like what it looks like. Sir, check it out. Here, if I take x of z common, then 1 minus z to the power minus 1 plus z to the power minus 2 minus z to the power minus 3, this is remaining. Now, if you see carefully, can I say numerator if I multiply with z to the power 3, denominator also we have to multiply with z to the power 3. And if I do that, I will get a proper positive version of this transfer function. So therefore, my transfer function, which is represented as capital H of z, it looks like z cube minus z square plus z minus 1 upon z cube. Now, a lot of students have problem in identifying the zeros. Sir, check it out, a cubic equation, how to get the values of zeros. Anybody in the comment section? What is the values of zeros? See, pole version is very simple. If I need the pole denominator equal to 0, z cube equal to 0, z is 0, 0, 0, third order. So, pole part is simple. What about zeros? Anybody? Check it out here. Pole can be said as z cube equal to 0, which means z is equal to 0, 0, 0. Okay, talking about the zeros, then if z cube minus z square plus z minus 1 is equated to 0, here if I take a z common, then z square minus 1, okay. So let me take a z square common. What will happen? Z minus 1. Sir, here also we have z minus 1. Now is it easy? Common factors, z minus 1 taken outside, the uncommons are inside, and now you will say this is equated to 0 and then this is equated to 0. Okay, so when z minus 1 equated to 0, z is equal to 1. When z square plus 1 is equated to 0, z square is equal to minus 1, which indicates z is equal to plus minus root minus 1, which is plus minus iota. Agreed? Then do let me know in the comment section. Yes. So we have third order pole at origin. This is third order pole, okay, at origin. And then we have 3 zeros. First at plus I, next at minus I, and finally at 1. So if you check now the options, you will say, sir, C zeros plus I, minus I, plus 1, and third order pole. Absolutely correct. Option A is correct. Option D is wrong because fourth order we do not have. Option B is wrong because we do not have 0 at minus 1. Similarly, C is wrong because we do not have 0 at minus 1. Agreed? Then do let me know in the comment section yes, so that we can move forward for the next question. So this was the second question of the day, and I guess this question is also easy, but now slowly you will see the toughness in the telecom 2020 paper. Let us see the third question, one of the good question. The output y of n of a discrete time system for an input x of n is given like this. Okay. The unit impulse response of the system is what? Option A 0 for all n, B is saying 1 for all n, C is saying unit step signal u of n, and D is saying unit impulse signal delta of n. So I will give you exactly 1 minute to solve this question. There is a trap in this question. I have seen a lot of students marking the options incorrectly because they are solving this in hurry. So you do not solve this in hurry. You take your time, you think, you solve. Okay, last 30 seconds to go. Sir, I am not able to understand what the examiner is asking. They are just asking the unit impulse response. They are asking you the output. But sir, what is unit impulse response? When you give the unit impulse input, then you get the unit impulse response. So this is indirect hint for the input data. This is indirect hint that x of n you have to treat as delta of n, unit impulse input. Okay, so that was the concept. Then comes the calculation. So let me write the concept first. This is your LTI system, linear time invariant system. You are giving input to this system. And what is the input? Sir, the input here is unit impulse input. Okay, so unit impulse input if you give, definitely you will get output which would behave as unit impulse response. Okay, so now check it out. When I say unit impulse input, this means x of n, because this was a discrete version, so x of n, that is equal to delta of n. Okay, unit means the magnitude, the amplitude here is 1, so unit, and then impulse, you know it very well, chronicle delta function. Okay, so now if I give x of n is equal to delta of n, what do you feel? What would be y of n? Sir, y of n is equal to maximum minus infinity less than equal to k less than equal to n mod of, instead of x of k, substitute delta of k. And then now tell me, what is the output matching with? Is it 0 for all n? Is it 1 for all n? Or else it is a special function, u of n or delta of n. Check it out. So to understand that, we'll say now, therefore, y of n is equal to maximum from minus infinity less than equal to k less than equal to n mod of x of k, and because we are saying that x of n is equal to delta of n, substitute here, it would be delta of k now. So maximum minus infinity less than equal to k less than equal to n, then we have delta of k. Okay, now let us focus on the calculation. This calculation can be understood more clearly by drawing the graph. Those students who are smart, they will say, sir, how slow you are solving, we have solved in seconds. But those students who require the clear understanding, उनका साबुन थोड़ा सा slow है. For those students, check it out. Delta of n nature. Delta of n works at n equal to 0 only. And what is the value? The amplitude is 1. What about the other stuff? When n is 1, the amplitude is 0. When n is 2, the amplitude is 0. When n is 3, amplitude is 0. Backward also, amplitude is 0. Backward also. Okay. So as you can see, in only at n is equal to 0, the amplitude is 1. Otherwise, the function is 0. When I say for n is less than 0, what will happen to this thing? Sir, you are asking for the negative values of n. So for negative values of n, y of n is equal to maximum value from k is going from minus infinity to the negative values, n is less than 0, and then we have delta of k. But sir, if I see the samples of delta of k in the negative version when n is less than 0, everyone in the comment section, what are the samples of the delta function in the negative side? Sir, all of them are 0. Yes, all of them are 0. Then what would be the maximum? Sir, maximum, all of them are 0. The maximum value would be 0. Yes or no? So here we have to say that delta of k is 0 always in this range. Okay, so here we have to say, let me write in this way, otherwise you will say, sir, delta of k is 0. ये देखो यहाँ पर n equal to 0 पर तो 1 है. When I saying delta of k is 0 always in this range, in n less than 0 range. Okay, therefore y of n is 0 in n less than 0. Okay, so let me take this calculation to the next slide, and this part is clear. When I am trying to draw the plot of y of n, if this is n, this is the amplitude of y of n, it is very much clear now by the calculation. If this is n is 0, the negative version n is minus 1, n is minus 2, n is minus 3, dot, everywhere the amplitude is 0. What about at n is equal to 0? What is the behavior when I say for n is equal to 0? Then sir ji, this would be y of 0, that is equal to maximum minus infinity less than equal to k less than equal to 0, and then a delta of k mod. Now you will say, sir, check it out, once you are changing the range, now you are saying the range is from 0 to minus infinity. In all these samples, take the maximum value of the sample. So the maximum value occurs, check it out, at n is equal to 0, we have 1 as the output. Other samples, other outputs are 0, right? So 0 and 1, who is maximum? Maximum is 1. Therefore, what is the answer when n is 0? Sir, when n is 0, y of 0 is equal to delta of 0 as the maximum from this sample, delta of 0, that is equal to 1. Okay, so exactly at n is equal to 0, this y of n is now 1. What about at n is 1, n is 2, and so on and so forth? Now you will say, sir, for n is equal to 1, y of 1 is equal to maximum k is greater than equal to minus infinity less than equal to n, but n is 1, so let me write it here 1, then mod delta of k. Again you will say, sir, go back and check. When you are saying that the range of n is from 1 to minus infinity, among all these samples, choose the maximum, then maximum is at n equal to 0, 1, we have maximum. Wait a second. I guess I am back again. Yes? So what I was saying is, I was simply saying that when you are saying the range is from 1 to minus infinity, and when I am checking this from n is 1 to minus infinity, what is the maximum value? Sir, at n is equal to 0, we have 1, and that is the only maximum. Therefore, I am saying in this range, again, the delta function is giving me the maximum output as 1. So, y of 1 is again 1. So, draw that in the graph. Y of 1 is again 1. What about y of 2? Now, you know it very well, sir. Y of 2 is again 1. And therefore, if you try to plot this, this would be 1, 1, 1, 1, 1. And this is the nature of what? Sir, this is the nature of u of n. Yes or no? If I copy this graph to the next slide, and if I ask you guys, isn't this the nature of u of n? What is y of n behaving as? Y of n is behaving as 1 when n is greater than equal to 0. It is 0 for n is less than 0. Therefore, y of n is u of n. This is the answer. Understood? Then do let me know in the comment section yes. Just for those students who are thinking, sir, how come y of 2 is 1? थोड़ा सा कैलकुलेशन मैं आपको दे देता हूँ ताकि आपको भी थोड़ी सी तसल्ली हो जाए. How come y of 2 is 1? Check it out. जगह कम है ना, बाकी कुछ नहीं, हमको देने में कोई हर्जा नहीं है, जगह हमको कम पड़ जाती है ना स्लाइड्स में. और इतना डिटेलिंग एक्सप्लेनेशन इसलिए दे रहा हूँ सो दैट यू डू नॉट हैव एनी डाउट्स after the class. Okay, check it out. When n is equal to 2, y of 2, what will happen to the range? Sir, when n is equal to 2, y of 2 would be maximum k is greater than equal to minus infinity less than equal to 2. Again in that range. N is 2 up till minus infinity. In all these samples, what is the maximum value of delta? Sir, the maximum value is 1. At n is equal to 0, we have 1. So, the maximum value is 1. And if the maximum value is 1, now you are very much happy that in all the positive sides, we'll get the output as 1, 1, 1, 1, 1. So, it will behave as a unit step function. Therefore, the correct answer is now option C, unit step function. So, one of the good question analysis in the graph to get the answer. So, let us move forward for the next question now. Check it out guys, the next question in front of your screen is very much dangerous because a lot of calculation is involved. हाँ डरा दो सर जी, पहली सब कुछ नहीं, मैं जो है वो बता रहा हूँ.